The conversation you're about to hear was recorded live at TWIMLCON AI Platforms. For more coverage of TWIMLCON, visit twimlcon.com/news or follow us on Twitter at TWIMLAI. But first, a word from our sponsor. Thanks to our friends at SIGOPT for being a founding sponsor of TWIMLCON AI Platforms. SIGOPT invites you to watch CEO Scott Clark's upcoming webinar outlining the critical capabilities customers prioritize when building machine learning platforms. He'll draw on experiences working with algorithmic trading firms that represent over $300 billion in assets under management, and enterprises with over $500 billion in market capitalization to summarize these trade-offs. Head over to twimlai.com/SIGOPT to register. Our next guest is Deepak Agarwal. Deepak is Vice President of Engineering at LinkedIn, and he's particularly passionate about the connection between the organization's investment in machine learning and AI and the value that it creates. And we're going to explore that in our chat. Let's get started by, I think everybody knows LinkedIn. It's not something that we need to spend a lot of time explaining, but...
How many of you don't have an account on LinkedIn? Okay, everybody, market saturation.
But let's maybe get started by talking about some of the ways that LinkedIn is using machine learning.
Yeah, so we often say at LinkedIn, machine learning is like oxygen, right? So everything we do has machine learning built inside it. Like if you go to LinkedIn, the first thing you want to do when you join LinkedIn is get connected to people who can help you. Now, how do we do that? We recommend you people that you can connect to. That's all powered through machine learning. Once you get connected to people, then you start consuming content that they produce on your news feed. And there is information overload on the feed. You can see so many content. So what kind of content do you want to see and when do you want to see? Like, for instance, if you're looking for a job, you want to see job recommendations. But if you're not looking for a job, if you're very happy and you want to learn more deep learning, and if you are connected to Andrew and he publishes something, then you want to see that on your feed. So you need algorithms to scale this process. Again, that's all powered through machine learning. If you are a marketeer and you want to target the right audience, the entire advertising ecosystem we all know works through machine learning. If you're recommending jobs that you can even if you're not looking for a job, we still recommend you jobs because there is always a better opportunity out there for all of you. That's all through machine learning. If you're a recruiter and you're trying to source candidates, it's all through machine learning. If you're a salesperson trying to close a deal, who are the decision makers? How do you reach to a decision maker? So everything we do on LinkedIn, product, whatever you see on the app, it's all powered through machine learning. And finally, this is something that goes behind the scene. We have to keep the site safe, right? There are a lot of bad actors out there producing content that should not even reach you. There are people who create fake profiles. I have seen a lot of fake profiles of famous people. That's not a good thing, right? So just to keep the ecosystem clean, that's again, machine learning plays a very important role in that as well. So everything we do at LinkedIn is powered through machine learning. In fact, when we create a new product idea, in addition to product managers, engineering managers, designers, we also have a machine learning person sitting there right when we are designing the product because we believe that's the right way to do things. The UI that you create, if that can actually build some important feedback loop, that can play a big difference. Andrew was talking about collecting label data. Well, how do you actually ensure that you collect the right label data? We have to actually start working on it at the design phase. It's too late if you don't pay attention to it at that stage. Mm-hmm. Then you have to build very complicated model that essentially do guessing, right? So you don't have to guess if you can actually get the right data. And so that's why it's very important to start that process from the very beginning of a machine learning process, of product process.
Yeah, one of the things that has always fascinated me in my conversations with folks at LinkedIn is we think of LinkedIn relative to a more traditional enterprise as kind of a digital native company born on the web. The product is web, but in a lot of ways, the company has evolved similarly. Its initial investments in machine learning and what the way it's supporting machine learning today are very different. Can you talk a little bit about the journey at LinkedIn and how ML and AI has evolved over the years?
Yeah, so LinkedIn was always a data-first company, right? Like, if you all remember, the word data science was coined by DJ Patil at LinkedIn. So we were always very savvy about data. We knew our business is all about the data, the unique data we possess, right? So we were always doing data science. We were always doing data product innovation. We also started doing machine learning very early on. Like in 2007, the first machine learning product, real product, was the people recommendations, right? So in those days, we would compute. We will have simple machine learning models, of course. So we'll have a simple model. The features of these models, there are a handful of features, but they're very carefully tweaked based on intuition. Once we have that model, then productionizing these models at that scale was still very difficult. So we will actually build Hadoop systems that will do the ranking and scoring offline, right? So because online was not very well developed. And then we'll run these processes every day, right? So search was another system that we actually developed very early on that used machine learning. Fast forward 2012, we got more sophisticated, right? So the first sophistication we added in terms of machine learning was in our advertising system, right? So the advertising system, most of our other recommender systems were based on simple collaborative filtering idea at those times. People who bought this also bought this, but then advertising was the first place where we added a lot of sophistication. We built near real-time systems. We built online systems that can score things at runtime, more complex models, and encouraged by the success we got there, we then attacked the feed problem, the news feed problem. For those of you who have been using LinkedIn for a long time, I'm sure most of you will tell me today the news feed is much better than what it was 5 years ago. And that's all due to machine learning, right? I mean, so a lot of work happened to kind of add sophistication to the news feed algorithm. And once we got success in these two big applications, then we started thinking of how do we generalize it across the board. Right? Why just advertising? Why just newsfeed? Why can't we build a platform that can actually generalize it to everywhere? And that's what we have been doing for the last few years. And so we have a program at LinkedIn called ProML, Productive Machine Learning. And again, I think a lot of companies have a platform. But I mean, one unique thing about our platform is, we are building a platform with a very strong opinion, right? So you can build a machine learning platform that can cater to a lot of tail users, right? So if you're a cloud company, you're going to build a machine learning platform that can cater to the needs of a diverse set of customers. That's not our goal, right? We know that our ROI is going to come from a few big applications. And the platform we have built is really suitable more for that, right? So large-scale recommender systems, large-scale search systems, large-scale classification problem. These are the problems that we face, and our platform is really geared towards that. Right? So we also know that we have reached a point where without adding more sophistication to our systems, you're not going to get the ROI that we used to get. So I give you an example. 2 years ago, for our job recommendation system, we revamped the model. We kind of moved away from a simple linear model to something more complex involving deep learning and involving something that is a homegrown technology called generalized mixed model. So I mean, I'm not going to technical detail, but these are very high dimensional model.
We had a lot with GMM.
Yeah, exactly. This is an old technique in statistics known since the 70s, and in statistics it was applied to application that 500 patients. Now those 500 patients become 500 million patients, and then suddenly the explosion in the number of parameters and complexity increases a lot, right? So we applied that, and we found a 30% improvement in result. And that was stunning, and so we were all very happy. But for the next 6 months, nothing happened. And then it was very surprising. Okay, well, did the engineers all go to Hawaii or what's happening, right? Why is nothing moving? And what we realized is when we introduced that complexity, the tooling did not keep pace with that, right? So it became very hard for the subsequent engineers to kind of iterate on this model because we didn't build the appropriate tooling that will enable them to kind of iterate. So that was the realization. We said, no, this is not going to work. As we actually start introducing more sophistication, the industrial process will only work if the engineers are still productive. And in order to improve productivity, when you add more complexity, especially for such large-scale distributed systems, if you really want them to run efficiently, if you want them to run in a reliable fashion, you have to make sure that the tooling and infrastructure can keep pace with the innovation that we are doing. And so that was really the impetus of this project that we kind of run called Pro ML, and we actually run it very rigorously. We are not just building platform components. We actually measure the success of that. So every week, we measure the number of successful experiments we have run. So there are a lot of experiments our engineers run, but we only track the number of successful experiments, right? Because otherwise you can start cheating, right? Like someone can just do a parameter sweep on the grid and say, okay, I did a parameter sweep of 100 different values, and so I ran 100 experiments. I don't care. I mean, you can run 100 experiments or 2 experiments. How many of them succeeded, right? So that's our metric, and we have seen like more than 30% improvement in the number of successful experiments that we run on the site after introducing this program. We're still not done. There is still a long way to go, but this has been really useful for us. It has kind of also brought the teams together. So earlier, if you don't have a standardized way of doing things, no matter how hard you try, the culture in the feed team would be different from the culture in the jobs team, right? And that's not good, right? I mean, we don't want to create different cultures in the same company. In fact, we want, given that we are a centralized organization, we want people to flow from one area to the other, right? So you did your tour of duty on the feed, and you should just go to the jobs team and learn about the jobs product, and you should be productive in a day, right? And that is only possible if you standardize things. And so this project has also helped us to standardize things and not kind of deviate too much.
Yeah, that's a really interesting observation. I talked to a lot of people who put the idea of culture against the idea of technology. In a sense, technology is not most important; it's culture. But you're talking about the relationship between the two, and technology supports creating the culture in an important way.
Yeah, so in engineering, the process, which is called CI/CD, right? Continuous integration, continuous development. If you look at different companies, they use different tools. And to me, that process, the tools you use, is actually a reflection of your culture, right? So the way you do machine learning really reflects the culture you're trying to build. Like for instance, there are many companies who actually build standardized tooling just for model creation. Once you've created the model, the deployment can happen in very different ways.
Yeah.
Now, I'm not saying that's good or bad, but that kind of tells you the culture of the company, right?
Mm-hmm.
We don't do that. We just want to standardize the entire end-to-end machine learning culture. And then, if you work at LinkedIn, that's really the culture that we have, right? Because we believe that's the best way for us to increase the ROI of machine learning. To increase ROI, there are several components. You have to be cost effective. How do you become cost effective? You have to be efficient. You have to be productive. And you also have to innovate, right? Because if you don't innovate, then no matter how productive you are, you're going to run experiment that will only give you marginal returns after a while. So the innovation has to continue, because innovation is not easy. We all know that, right? If you don't innovate for the next 6 months, you certainly would not stumble upon a breakthrough that's going to completely change the game, right? So you have to continuously innovate, and you cannot give your engineers time to innovate if they are not productive. If they take too much time to do their job, when are they going to get the time to innovate, right? So innovation, productivity, efficiency, and those are 3. So innovation, productivity, efficiency, like these things, they are all entangled. They all have to be attacked together. You cannot just say, oh, I'm not going to worry about productivity. I'm just going to worry about innovation. It doesn't work that way, right? Because, the time that an engineer has and, the kind of investment you can make in the program is fixed, right? You have a fixed budget problem, and you have to really solve these 3 components in the best possible way, depending on your business needs.
Yeah. So we've talked about platform abstractly thus far. Can you give us an overview of ProML and the kind of major components, what's in place now, the direction you're heading with it, et cetera?
Yeah, so our aspirational goal is the entire end-to-end machine learning process should become completely automated, right? Like once a scientist understands the business problem, they understand the kind of models they need to build to solve that machine learning problem. From there on, everything else should become automated. And obviously, that's very easy to say. We all know it's not very, it's very difficult to do. I don't think anyone has solved that, but that's the aspiration at least. So just like any other end-to-end machine learning platform, we have a model creation process, right? So how do you create models very easily? How do you compose different kinds of ideas together? Like if someone wants to take XGBoost and GLM Mix and neural network and try it out, like it should be very easy to try that. So model creation, data preparation, That's one major component. Once you have built that, then how do you deploy these models in production? Once you have deployed the model in production, then how do you make sure that you're not babysitting the model, right? We don't want our scientists to become babysitters, right? Because that's not a good way to run a machine learning program. So the maintenance of these models, once they're in production, should be almost automated. And what do I mean by that, right? If the model is running in production, you still have to retrain the model because the world around you is changing every day. It's not a stationary process. So every day the data should flow in the directory automatically. If for whatever reason the data does not flow, there should be an alert, and the person who's running the model should kind of know about it, and then they should have a fall off, graceful degradation. If everything is going well, then the data should come in, and you should be automatically building systems that can retrain the model and deploy it in production without any issues, right? And so this should not require any human intervention, right? The rest of the things, model creation and all that stuff, that's where the scientists need to spend their time. So one unique feature that we have added to this entire ProML, which may be distinct from other, is we created this notion of a feature marketplace. Right? So we all know in order to create machine learning models, features are the most important thing. And so we don't want the scientists to be starting from the scratch, right? So there is a marketplace where we have actually created a lot of features for you, right? Think of them as prefabricated features, right? For instance, based on all the activity of users on the site, we know who has a strong job intent. We know who clicked on an ad in the last week. So these are features that are all available to you. Based on your profile, we know, what are your standardized title and all that. So if you want to build a machine learning task, you can just grab these features from the feature marketplace using a consistent API. We call it Frame. And that makes it super easy for you to start building a model right from the very word go. And you will actually reach 80% there, right? That's very easy. Now, if the additional 10% improvement can add a lot of business ROI, then you better spend more time on that, because otherwise the first cut should be something that you should be able to do very quickly.
Mm-hmm. So I alluded to this earlier, but and you did as well. LinkedIn was very early on in this space. You made initial investments based on your technology landscape at the time, very Hadoop centric, but that's needed to evolve over the years. Can you talk about that evolution and the challenges that it presented, the way you managed it?
Yeah, so that was not an easy journey. So I think when we started the advertising problem, for instance, we wanted to do very large scale modeling, as I told you. But Hadoop is not very amenable to that kind of computation. So we actually did algorithmic innovations to do those distributed computations. So for instance, the first version of model fitting algorithm we launched on the site was based on ADMM, right? So ADMM can actually help you do computation in pieces, and then you can patch it all together by using a simple computer. And that was very amenable to Hadoop. And that's how we started. We got the ball rolling, and we saw enormous ROI in our system. And then Spark came along. We are one of the very early adopters of Spark, even when it was not very stable. And so we believed that Spark is going to solve a lot of our problems. So we invested very early in Spark. We worked, in fact, with folks in ML Lib. In fact, a couple of the folks who actually joined ML Lib were at LinkedIn. So, okay. So we had a great relationship with them, and we then really focused on made Spark a first-class citizen in our ecosystem. That helped us a lot to scale these algorithms. And then finally TensorFlow came in, right? When with the deep learning, we again took TensorFlow. TensorFlow in those days had a lot of great things, but it didn't have everything that would help us deploy it end to end, right? So we had to build things like Tony and other things that we have open sourced. So that's been really our journey. And I think all along we had very strong support from the business to do what we really needed to, because the ROI was always there. So that is the key lesson for me, right? Whenever you're building a machine learning program, when you're going to your executives, just show them the money, and then everything else becomes much easier. If you can't prove the ROI, then it becomes hard.
Show me the money.
Yeah, right. You can do a lot of research, but the program should add tangible and direct value to the business. And if you can ensure that balance, I think you are in great shape. Then you get all the support you need. Because otherwise, going to your executive team in the early days of deep learning and telling them, okay, you need to help us get a GPU cluster, it's going to cost $20 million. It's not a very easy argument to make. I mean, you have to wait for a while before they actually buy into that. But if you have a track record of delivering, then these things work out much more easily.
We alluded to this in my conversation with Andrew earlier. You have to manage that portfolio and expectations very carefully.
Right.
You know, what you can deliver near term, what the overall vision is. How have you done that?
Yeah, I think you just described my job. But yeah, so I mean that's what a portfolio manager would do, right? So I mean I have this philosophy, as I said, like so there are three components to your portfolio. One is the core investment. So this is something that you do to add value to your business on a consistent basis. Like, is machine learning able to improve the number of the engagement that members have on our site? Is machine learning able to help us create more revenue, help our customers have a better experience? Is machine learning able to keep our site safe and clean, right? So these are core investments. We cannot afford not to do those, right? So that's the bulk of the investment. Like I would say that's 60%. The other 30% is more strategic investment. So we know that deep learning is going to help us in the next 6 months. And after all the model iteration that our engineers are doing with Pro ML, even if they can do a lot of iteration, after a while, these methods are going to only give marginal gains. In fact, it will actually put us in a lot of trouble because there will be so many experiments queued up, and the amount of experimental budget you have is still constant, right? You cannot run hundreds of experiments on the site, even if you can, because the experimental budget is fixed, right? So you have to invest in strategic initiatives so that in 6 months you get something new which is going to give you a big gain, right? And so the experiments you are running will actually still produce a lot of ROI. So that's the strategic bucket. And the 10% is more venture bet, right? So new product ideas, things like, okay, how can we do deep reinforcement learning and productionize it in the future? How do we build chatbots that can change the entire way users interact with each other on LinkedIn? These are all venture bets and ideas. So that's roughly the portfolio we try to maintain, like 70, 20, 10. And so far it has worked pretty well. We also do other things like to encourage grassroots innovation. We have something called the Ideas Program. So every quarter, anyone in the organization can actually submit an idea they want to work on. And then there is a committee who actually looks at all the ideas, and we'll select the top 10 ideas, and those ideas get funded through our normal resource pool. So this is just to make sure that everyone, it's not always top down. The ideas are not always top down. There are some, and some of the ideas, some of the best ideas we have seen actually come from that grassroots innovation. So your organization is also very energized. They know that we are in the innovation business here, right? This is how we actually produce ROI, right? So it's also important to create that culture of innovation. We also organize hackathons so that folks can actually experiment with new product ideas or build prototypes and so on and so forth. So it's really that culture that is very important, I think, that helps you kind of create that energy and keep doing that innovation. And then we have an awesome infrastructure team that actually partners with us to make sure that we are productive and we are efficient. Right?
Okay. You mentioned earlier that you're very deliberate about measuring the experimental velocity of teams at LinkedIn. Can you dig into that a little bit deeper?
Yeah, so just as we have a centralized AI organization at LinkedIn, we also have a central experimentation platform. Right? So every A/B test you run, we document that, we log that data. And based on those A/B experiment, we have readouts of things that succeeded in production. So we kind of aggregate all of that information and make sure that we kind of have a dashboard, and we look at it every week, and we measure things just as we will measure any business metric, just as you will, and just as in your business metric, there are seasonality, right? Like in the summer, people take vacation and we see a drop. If I see a very big drop, then that's an alarm bell, like what is happening. And then I realize, oh, well, everyone is attending a conference. So, okay, well, that's why we didn't have enough experience. So we are very deliberate and we are very particular about that. We've in fact enhanced it now, right? So now we started with the total number of successful experiments. Now I'm asking even the teams to label their experiments. So is it a large t-shirt or medium-sized t-shirt or a small t-shirt, right? And it's very interesting how teams kind of put those labels, and then we discuss about it. Like you can give a hard time to your teams in a good way. I'm a good manager, so like, why do you think this is a large experiment? And it's okay. Do you think you can't think bigger than this? And so it's actually a nice thing for you to even get a sense of the culture that you have in your organization, like who thinks what is big, what is medium, what is large. And over time, you can actually create this culture where you are actually asking folks to run fewer numbers of larger experiment, because it is great to say we can run a lot of experiment, but every experiment has a cost associated with it. And I don't mean infrastructure cost only, I mean opportunity cost. Right? If someone is running an experiment, they're going to wait. Then after 2 days, they're going to look at the results. And then they're going to move on to the next idea. So this is a hidden, economists call it the hidden cost, right? So there is a cost to every experiment you run. And the best way for an organization to become really effective is to run a large number of high-value experiments, not a large number of experiments. Right? That is not enough, right? I mean, because in many cases, I've seen people run parameter sweep experiments. I mean, those experiments should be all automated.
Yeah.
So you have to actually have forensics on the experiments as well. Right? Once you become a large organization, the next step is to kind of analyze, have telemetry on your experiments, and then figure out what experiments can be automated, and encourage your engineers to work on the big things rather than on things that can be automated.
You mentioned in opening things up that LinkedIn was very early in adopting data science, and in that period of time, once that term caught on, everyone who worked in this space was a data scientist. Since then, the roles have evolved. We've got machine learning engineers, we've got platform teams. What does that evolution look like at LinkedIn, and where do things stand now?
Yeah, so that evolution, like in any other place, is still evolving, like we all know. I mean, to me, there are 4 pillars of AI or data science, whatever you call it, and that's how, actually 5. Machine learning, computer science, of course, that's the key. Then statistics, optimization, and economics, and systems engineering, right? So these are really the 5 pillars. And when people from these 5 disciplines come together and work together to solve hard problems, that is what creates the magic. Right now, I think labels are labels. They keep changing over time. I don't think at LinkedIn we pay too much attention to the labels. We just make sure that these 5 disciplines can always come together and work. And then, so that's the technology side. But technology side is also not enough to create awesome machine learning solutions. Like, for instance, the most important thing in a machine learning problem is to define the problem. Right? What are you trying to solve? And you cannot define the problem unless you interface very closely with the domain experts. So you have to work very closely with the product team. And in this day and age, you have to worry about security, you have to worry about legal. So you have to interface with the legal team. Right? So it takes a village to get AI right. Right? And so I think that's how we think about AI at LinkedIn. In order to actually make sure that everyone understands the basic of AI at LinkedIn, we have actually created what we call the AI Academy. And so it has 3 levels of courses. The AI 100 is general awareness. In fact, I also teach there because I'm passionate about teaching, right? So this is like a 2-day course. We have our best people kind of teach to everyone in the company what AI is all about. And it starts from data, right? I mean, you cannot be an AI-first company without being a data-first company. Because at least today, we don't know how to do AI without data. Maybe in the future, we may create a new theory that can help us do AI without data. But right now, we all know we need data to do AI. So data first to AI first. And that education is a very important component. Then we have AI 200. So if you are an engineer who has taken Andrew's course but now want to get your hands dirty, you can actually get your hands dirty through AI 200. And AI 300 is an internship program. So you can be an intern in the AI organization. Someone is going to work very closely with you, and you will be actually deploying things in production, right? So the education and this collaboration and tooling, this is really how we run AI at LinkedIn. And we always say AI, it takes a village to get AI right. And we have seen that firsthand. If you try to create an AI program in a company in a silo, it would never work, right? You just have to do it together. It's too big to be solved by one discipline, is my opinion.
So maybe to start to close out, I'd love to hear your vision for where ML is going at LinkedIn, and maybe even more broadly in the industry.
Yeah, so I think we have reached a point where deep learning is really helping us a lot, and we are able to solve some very traditional problems that were very hard to solve in a very spectacular way. But I still think, as I think Andrew was also talking about that, machine learning is still not very accessible broadly, right? Only a few companies that have that have the talent and that have the culture that they've built in the space for a long time, they are the ones who are really reaping a lot of benefit now. So how do we make machine learning more accessible broadly so that everyone can benefit from that? I think that's a very challenging problem. It's not easy, right? Like, if you don't even understand how to manage data, to think that one fine day you will just wake up and run a deep learning model and it will all start working automatically, that's a pipe dream. Right? That doesn't happen, right? So getting there would be a very big task for us. Once we get there, then I think the computational cost is also something that we all have to think about. So GPUs are not just costly, they are also bad for the environment, right? And so, we don't want a planet where we are actually doing so much compute without being careful of what we are doing to our environment and to our planet, right? So if you want to be cost effective, you have to figure out ways to kind of do the computation in a more efficient way. I think that I believe it's going to become a very important topic for all of us. And finally, responsible AI, right? And again, I don't want to steal thunder. There is a panel on this later at the conference, but doing AI in an ethical way, doing AI in a responsible way, making sure the privacy of individuals and everyone else is kind of adhered to, and we're not having data breaches and all that stuff, right? So that's, again, a very important topic for all of us, because there's no point in creating a very powerful technology if it works against the humans, right? I mean, we need to create technology that helps us become better, right? And so this is, again, another big area for all of us to think about in the future. It's not about where this will go. It is all about where we want to take it to, right? So this is one thing where I don't want to make a prediction. I want to kind of appeal to all of you that we all think about it very deeply and make sure that we are all using the technology in a way that is going to help the human race, not hurt the human race.
Awesome. Well, Deepak, thanks so much for joining us.
Thank you. Thank you.
All right, everyone. I hope you enjoyed our show straight from the main stage at TWIMLCON AI Platforms. For more information about today's show, visit TWIMLAI.com. And for more TWIMLCON coverage, visit TWIMLCON.com/news. Thanks so much for listening, and catch you next time.